Hey guys, it's Miss Miklos. Hopefully you guys can hear the rain in the background, because how often does that happen here? But anyways, back to math. I wanted to walk you guys through how I did the problems on our review, since you guys did, or not on the review, on the identity worksheet, since you technically didn't have all of these, and I want to make sure that you guys are in good shape. So the first two we did in class together, but I just want to make sure we're okay. So to save time, I already have my work written out, so I'm just going to talk us through this. So it is asking us to verify, so that means we need to get the two sides equal to each other. So I took cosine to the fourth minus sine to the fourth, and I realized that that was difference of squares. So I could write that as cosine squared minus sine squared and cosine squared plus sine squared. Using our Pythagorean identity, I know cosine squared plus sine squared is 1. Cosine squared minus sine squared fits our double angle identity, and that's actually cosine of our double angle. Cosine of our double angle times 1 is cosine of our double angle, and we are done because we have gotten the two sides to equal one another. Okay, 17 we also did together in class, and once again, the way that I'm doing them, not necessarily the only way, it's just the way that I thought was maybe the quickest or what came to my mind first. I chose to change all four of these into terms of sine and cosine, which you guys can see written here, and I'm assuming we're feeling good on doing that. But since we had a complex fraction, I chose to multiply everything by the overall LCD, which is sine cosine. So when I distributed to all four of these terms, I got cosine squared minus sine squared over cosine squared plus 1. And that works out super nice for us because I know cosine squared plus sine squared is 1. Cosine squared minus sine squared is our double angle formula, so I get cosine of our double angle equals cosine of our double angle. Okay, moving on to 18. This is the one we started in class and kind of ran out of time, so I just want to walk you guys through what I decided to do. So I started here. I knew cotangent is 1 over tangent. And the reason why I thought to do this is because we don't have a cotangent double angle formula, but I know our tangent double angle formula. So I'm going to kind of talk about the left side and then I'll get to what I did on the right side. So what I did here, I made this 1 divided by, and this is our double angle formula for tangent. I know when we're dividing by a fraction, it's like multiplying by the reciprocal. So I have 1 minus tan squared over tan, and that's how, 1 minus tan squared over 2 tan, and that's how we're going to leave the left side. On the right side here, I honestly right away wasn't quite sure what to do, so I noticed I have a monomial denominator, so I thought, well, why don't I divide both of those terms in the numerator by 2 cotangent? So when I simplified this, I noticed that I could cancel out these cotangents, and I was just left with cotangent divided by 2. Our other term, I know 1 over cotangent is just like tangent, so I wrote this as tangent over 2. At this point, I had tangent minus cotangent over 2. And looking at the left side of the equation, I noticed I needed 2 tan in my denominator. So because of that and that alone, I chose to multiply the numerator and the denominator by tan. When I distributed, some really nice things happen. Tan times cotangent, those are reciprocals, so that's 1. Tan times tan is tan squared, and tan times 2 is 2 tan. So I got my two sides to equal one another. For me, I thought this was actually the toughest one on here, just because we really had to use both sides of the equation, and we had to use the information given to us to determine what our next step should be. Okay, number 19. Cotangent squared over 1 plus cosecant equals 1 minus sine over sine. I decided that the right side of the equation was the most simplified and the easiest to work with because we had a monomial denominator. So I'm just going to show what I did on that side first. I split it up, so I did 1 divided by sine minus sine divided by sine. And then when we simplify that, I know 1 divided by sine is cosecant, sine divided by sine is 1. And I kind of left it just like that, and my goal is going to be now to get the other side of the equation to look like that. So on the left side of the equation, I noticed cotangent squared is one of our Pythagorean identities. It's cotangent squared plus 1 equals cosecant squared. So I replaced cotangent squared with cosecant squared minus 1. The reason why I thought to do this is because I noticed that I have a 1 plus cosecant in the denominator, so I'm thinking somehow we can cancel some stuff out here. In fact, cosecant squared minus 1 is difference of squares, so I went ahead and factored that, and then I canceled out our like terms, and magically, I was left with cosecant minus 1. Number 20, I decided that the left side was easier to work with, so I started by getting those in terms of sine and cosine. And I thought to do this simply because the right side is in terms of sine and cosine. The nice thing here, we do have a common denominator, so I made it 1 plus sine over cosine. Now I noticed that on this side of the equation, I need to have a 1 minus sine in my denominator, so I multiplied by 1 minus sine over 1 minus sine. And just to review, the reason why I can do this is because that's really like multiplying by 1. So when I multiply, I get 1 minus sine squared over cosine times 1 minus sine. And I left it like that because we know 1 minus sine squared is cosine squared. I can simplify these cosines, and I am just left with cosine over 1 minus sine equals cosine over 1 minus sine. Number 21, in order to do this one, you guys needed to remember that tan cubed minus 1 fits our difference of cubes pattern. So I know our A value is tan, our B value is 1. So our pattern goes AB, A squared, AB, B squared. And our signs go SOAP, so same, opposite, always positive. Once I factor that, I notice that these two binomials are the same, and these are equal to one another. And that's it. Okay, number 22, I have cosine squared 2x minus sine squared 2x. I noticed right away that this is my cosine double angle formula. So I wrote it as cosine of 2 times whatever our angle is. Normally this angle right here is just x, but in this case it's 2x. So I have cosine of 2 times 2x, which is cosine of 4x, equals cosine of 4x. Okay, number 23, a little bit more work. I did two things in the first step. Obviously, this left side looks more complicated, so I worked with this parenthesis, and I noticed that it was 2 times 2 sine cosine. And the reason why this was significant to me is because 2 sine cosine is one of our double angle formulas. 1 minus 2 sine square is a cosine double angle formula. So I went ahead and made this 2, that's where the 2 comes from. 2 sine cosine becomes sine 2x, cosine 2x. Now I know I'm not done because these two things are not equal yet, so what jumped out at me is this is actually 2 sine cosine again. So it is sine times twice whatever our angle is, so we get sine of 4x. I know I'm going through these super quick. If you need more help on one of them, please feel free to come in at lunch sometime. But hopefully with just hearing my words along with the writing, you guys are on the right track. Okay, 24 says cosecant of 2 theta. Once again, we don't have a cosecant formula, so I decided to make that 1 over sine 2 theta. This then would be 1 over 2 sine cosine, because I know sine of 2 theta is 2 sine cosine. And looking at this other side, I know this 2 cosine is good. I just need to change this 1 over sine. I know 1 over sine is equal to cosecant, so I just went ahead and wrote cosecant over 2 cosine equals cosecant over 2 cosine. So hopefully this quick review either really told you what was going on, or it just affirmed what you already knew. And for those of you that care, here we go. There's our lightsaber. I can't even call it anything. Just for fun. But keep studying. Definitely expect to see this level of problems on the test. And please come in if you need help.